Thank you. Morning, everyone. Thank you for your time. Thank you, Simone, for this kind introduction. I feel honored to be here on behalf of Lanxess. My name is Pedro. I am a chemical engineer. I studied at the São Paulo University, and now I've been working with polymers since last year. I'm now a development and technical analyst at the urethane lab in the city of Porto Feliz. Okay, so first, sorry, I'm just doing some tech adjustment here. Should I stand here? Okay, so we have 4 different types of polymers: the elastomers, the adhesives, and the polyester polyols, as well as coatings. So elastomers is the most broad application: petrochemical, oil and gas, on the wheels of industrial machinery. Now then we have trixene wet coat bond, and that is for the textile and also linings in general for the automotive industry. You also have adhesives. They can be applied on the field in external areas as well as inside the plant. And we have the polyurethane foams. They are very versatile. They can be applied on metal, plastics. Now, Lanxess has a very large client portfolio, and we are leader on the low-free technology for elastomers. We have more than 60 years of experience. We have 6 productive plants around the world. We have 8 centers for development, and we have 1 R&D specific in the US. We have more than 500 SKUs for our clients, so depending on what you need, we can also develop something for you. We have surpassed 250 million euros in sales in more than 60 countries, and we have more than 400 employees all around the world. In this map, we can see how Lanxess is distributed all around the world. So our headquarters are in Germany, but we also have productive plants and application development centers in the other continents. And then we have our R&D in the US. We have the installations, the facilities in Porto Feliz where I work. Also, we are present in China, Europe. Now, how are we able to promote so much innovation? That is due to our investment in technical capability. In Naugatuck, in Connecticut, in the USA, we have our global R&D. There we have the most state-of-the-art, next-generation equipment, and we are supported by them all around the world. We also have the other development and application centers around the world, in Americas, Naugatuck, and Porto Feliz here in Brazil. Then India, China, and Australia. And in Europe, we have centers in Italy, the UK, and Germany. Now, how does it look like in the practice? We have 2 areas of expertise: Lanxess and the customer's expertise. So we come from the association from polyol and dilsocyanate, and we can also add any sort of additives that may be catalyzers, plastifiers, according to what the customer needs. And we provide the source of the cure agent that will help in the finishing of the will help with the finishing of the product. Whenever the client feels that they are facing some difficulty in handling the material, they get in touch with us, and we're always very happy to help. And then enters the customer's area, which is the curing process, the curing agent with the different additives, and depending on what they need, we can answer to that. For example, we have the polycast, which is our pre-polymer that doesn't need to be heated. You can do all of the curing process in room temperature. We've been working a lot with a PU spray, which is the polyurethane in spray. We can work with a low strength PU as well, and we can have the isocyanate in blocks. So depending on when you need it, then you're going to handle and apply the material. Now, innovation and safety walk hand in hand at Lanxess. That's why I'm so proud to bring you Vibrathene MS 630F, which is the first flame-resistant pre-polymer. It has been developed here in Porto Feliz, and it's being produced as we speak. We have already many buyers, many companies have chosen to work with this pre-polymer that has been certified. And why did we develop it? Well, especially when we talk about mining and oil and gas, there's a lot of displacement of material in different means, and they may get stuck with the heat, maybe a fire may start. So depending on the material that you're using on the conveyor belts, that can worsen the situation, can further spread the fire, leading to a lot of financial loss and even human losses. That's why there's growing demand for a polymer that is more fire retardant or fire resistant. Here I bring to you some initiatives, some situations, some cases in which a fire occurred in the conveyor belts, and due to the belt material, that fire is spread. So huge loss to the companies. Here we can see what happens to a conventional polymer when exposed to flame. So we can see that there is a leaking of the material, and the polymer also makes the fabric below, it leads to it catching fire. So we developed a project thinking about two main points. The first point was to assure the fire resistancy via the UL 94 stand class V0. This standard, it says that when a material is exposed to flame for more than 10 seconds, it cannot have any drop-in, it cannot have any sort of shine, and as soon as the flame stops, it should stop burning. It's no good having a flame-resistant material, though, if it does not match the physical properties of a standard pre-polymer, right? So we had to assure the material properties. We have three methodologies. There is a methodology used to determine the flammability classification, the rating, that could be V0, V1, or V2. We focused on V1. That is no spreading of the fire and no drops from the material. So at Porto Feliz, we were able to develop this material that associates a high performance and the flame resistance. As I've told you, this has been certified by IPT. It is mocha free, so we are not using mocha as a curing agent. It is a high performance material. And we're not using mocha because as time goes by, people realize that some of these materials may be harmful, and it is locally produced. This is the Vibrathane MS630F test. So you can see it is catching fire, obviously, but there is no drops. And as soon as we remove the flame, the fire extinguished. That's been a huge advance for polyurethane. Now, telling you about the properties of this material. In this chart, we can see that the shear strength and the strength, the hardness properties remained the same, as well as tear resistance. Then abrasion and the tear resistance just a little bit lower the performance, but that can be corrected. Here you can see our IPT certificate, which makes us very proud, claiming that our material is flame resistant. It will not lead to any dripping or spreading of fire. Now, what are the next steps for our material? We would like to expand the 86 Shura hardness range of our material. We would like to expand that hardness range. Also, we would love to work with other chemical composites. Besides MDS, we would like to work with other prepolymers and make them flame resistant so we can have more applications beyond oil and gas, petrochemicals. We would like to go to the agro, textile as well. So we are always working hand in hand, innovation and safety. These are the sales team contact details, as well as the technical team contact details. Do get in touch. We love to showcase our technologies. We are always welcoming clients at Porto Feliz, showing them our labs. We like to show people as well how to process the material. And I would like to thank you all for this opportunity. As a chemical engineer and a Lanxess employee, I feel very, very happy to work with a material that truly promotes safety and security, using chemistry to make the world safer. I believe is our duty, and as a chemical engineer, I feel very gratified. Thank you so much, and I'm here for your questions. We have one question, Pedro, but first, let me congratulate you. This is Pedro's premiere in presentations. Great presentation. So first, what are the MS630F processing conditions? Great question. It is very close to the conventional. So we use butanediol as a cure agent at room temperature. The pre-polymer we are going to heat up to 60 degrees Celsius, and then we have the pot life, the time that we can work, handle that material of 10 minutes, and then it depends. If the pre-polymer is a bit hotter, then the pot life shrinks. We have a release time of up to 60 minutes. In 60 minutes you can release it from the metal mold, and the post-cure of this material is 16 hours at 100 Celsius. These are the conditions. Okay, great. One more question, Pedro. We want to put you in a ring of fire, Pedro. Since you are a rookie, we have Yulton here with us in the studios as well. So we are going to give you a bit of a hard time. Pedro, is there the possibility for new developments that are TDI based? New developments TDI based? Okay, for TDI we need to be careful with the cure agent because butanediol will not provide the ideal polymeric conditions, but we can develop some alternatives. But this would be a next step to produce it with new materials. Now, what do you expect to be the marketing of this new material in the South American region? Okay, well, in the South American region, we have a vast mining industry with a large use of conveyor belts and mobile parts, so we believe that this new material is ideal for the safety of the process. Should you have a fire, having a material that prevents that fire from spreading, that is of utmost importance to minimize losses and most importantly to save lives. Great. That was our last question. So let me now join you on the screen. Pedro, thank you so much. We hope this is the first of many times that we're going to hear from you. Thank you so much.